Hey everyone, today we're going to be talking about homework number 14. This was dealing with section 8.5, and our lesson for today was solving logarithmic and exponential functions. So your first set of equations, you guys are going to be doing 1, 2, 4, and 5. It asks you to solve each equation round to the nearest 10 thousandths. So let's go ahead. I'm going to do number 3, walk you through that one, and hopefully you guys can figure it out from there. So number 3 looks like this: 5 raised to the xth power equals 81 and 2/10. So when we're solving these, we're just going to use inverses here. And remember, right now I see an exponential function. The opposite of an exponential is a logarithm. And if you look closer, the base of my exponent is a 5, so the base of my logarithm better be a 5 as well. So when we're solving this thing, we're going to take the log base 5 of each side, and if you remember from class, and kind of what I was just saying a second ago, these two things are inverses of each other, so they're going to simplify each other away. So on the left side, I'm just left with x. On the right side, I'm left with log base 5 of 81.2. So at this point, remember, your calculator can't do a logarithm unless it's base 10. So we're going to actually take advantage of our change of base equation now. So to solve this thing, remember, we can always change the base. We're just going to do log base 10 of 81.2. That's going to be our numerator. And our denominator will be log base 10 of the previous base, or 5. At this point, we're just going to pull out our calculator and finish this problem up. So when I do log of 81.2, I'm going to get about 1.909556. When I do the log of 5, I'm going to get about 0.69897. And then I just simply do that division. So I'm going to do 1.909556, and I'm going to divide that by 0.69897 and get us a grand total of x equals 2.73195. So remember, at the beginning of the problem it said round to the nearest 10 thousandths, so we have tens, hundredths, thousandths, 10 thousandths. If I look at the next decimal, I have a 5, so that's actually going to make that round up. So I'll get a final answer of x equals 2.73, and since this is a 9, it's going to go up to a 0, which is going to have to make this one go up one more as well, and I'll get 2, 0 here. And there's my final answer. Alright, so moving on to your next set, you guys have questions 13 and 16. These ones say solve by graphing, so I'm going to just kind of walk you through the steps. So I'll even actually kind of do the one that you have to start with. Seeing as I'm not really going to be able to show you what the graphs look like, I'll just kind of go through the steps of this first one. So on 13, I have 4 to the 7x equals 250. All I'm wanting you to do here is go into a graphing calculator. If you have a TI-83, 84 graphing calculator, awesome. If not, just pop into Desmos. You're going to make 2 equations, or you're going to graph 2 equations. Y1 is just going to be the whole left side, 4 to the 7x, and y2 is just going to be the right side, 250. Okay, when you graph these, just scroll out and you'll see a point where they intersect. Wherever that point of intersection is, it's going to be whatever your x value is there, that's your answer. So you get x equals and then whatever your point of intersection is. Alright. Alright, moving on to your third section, you guys are going to be doing questions 25, 26, and 32. Here it says use the change of base formula to actually evaluate each one of these logarithms. So what we're going to go ahead and do here, I guess I'll go ahead and do question, let's do 27. So question 27 says we've got log base 3 of 54. So remember our change of base, we can change any base. Here we have 3. Clearly we want a base of 10, so we can actually use our calculator to solve this thing. So when we do that, you're going to get log base 10 of whatever you're taking the log of in the beginning, and that's all going to be divided by log base 10 of what your previous base was, or this 3 down here. When we plug that into our calculator, we're going to do log 54. Gets us our top of about 1.73239, and we do our denominator. We do log base 10 of 3, and we get about 0.47712. Okay, at this point, we just do our little division here. I can take 1.73239, and I'm just going to divide that by 0.47712. When I actually do that division, I will get a final answer of y equals 3.63. And then it says 0.9. I'll just round it to the nearest hundredth for this set of problems. It doesn't specify, so let's just go 2 decimal places here. Alright, so that's the first part. It then also says, hey, let's convert it to a base 8 as well. So that one, there's not a whole lot of math behind that. We're just going to go ahead, take our original problem. Instead of making it base 10, we're going to make it base 8 to make a brand new expression here. So if I make it base 8, just go log base 8 of 54 all over log base 8 of 3. So this part, this second part, is really just kind of getting at the fact that you get to choose whatever base you want. I don't know why they chose base 8, but we're just kind of going through the process of saying, hey, it doesn't matter if it's base 10, base 8, base a million. We can just choose whatever base we want using this equation. Alright, your second to last set of questions is going to come starting at 33. You guys are going to be doing 33 and 34, and these are solving logarithmic equations. So I'm going to go ahead, let's do question 39. That's kind of like what you'll see in 34, and that's the little trickier one. So in 39 we see 3 times log x equals 1.5. So the big thing to realize here, remember, if I don't specify a base, it is the common log. So this is log base 10. So remember from class, the first thing when we're solving a logarithmic or an exponential equation, we need to get the log or exponent by itself. So right now I see that we're multiplying by 3, so I'm going to divide each side by 3 to get these to go away. I'm going to be left with log base 10 of x is equal to 1.5 divided by 3, or 1/2. Okay, at this point, I need to undo this logarithm here. Remember, the opposite of a logarithm is an exponential function that has the exact same base. So what we're going to do is turn the left side into one big old exponent. This is 10 raised to the whole log base 10 of x. So remember what that does. The 10, log base 10 cancel out. If I turn the left side into the exponent, I better turn the right side into an exponent as well, or 10 raised to the 1/2 power. At this point, now it's just kind of a plug and chug. Left side, I'm just left with x. On the right side, I have 10 to the 1/2. When I put that into my calculator, I'm going to do 10 caret 0.5, or you could do 1 divided by 2. Make sure you put that in parentheses if that's what you do. And I get my final answer of x equals 3.16. Alright, now to finish up this homework, you guys will see questions 42 and 43, which were ones that I made myself. So if you are following along with the book, you will not find them in the book. I have them just typed into your actual homework assignment. So I'll just do one that's similar. Let's do one that's a little more like question 43. So we'll just, for reference, call this question 44. And here we'll do 1 plus 2 log base, let's call it 8 of x plus 4, and we're going to say that's equal to, let's go ahead and do 5. Alright, so just like the last set of problems, the first thing we need to do is get our logarithm by itself. So don't even worry about the base being 8, and don't even worry about what's going on in the parentheses. Our first goal is to just get everything else to the other side. So over here I see a positive 1, so I'm going to subtract 1 from each side. That's going to leave me with the resulting equation of 2 log base 8 of x plus 4 is all equal to 4. Again, trying to get this log by itself, the opposite of multiplication, we're going to divide each side by 2, and I'll get a resulting equation of log base 8 of x plus 4 equals 4 divided by 2, or just simply 2 here. Okay, at this point, we see our log base 8. We want to get rid of the log. Remember, to get rid of a log, we make an exponent that has the same base. So we're going to do 8 raised to this now giant exponent of log base 8, x plus 4. If I turn the left side into an exponent, I better turn the right side into an exponent as well, which is just 8 squared. And using our inverse rule, hey, our exponent and our log cancel each other out, and I'm left with x plus 4 is equal to 8 squared. So at this point, just finish up solving this problem. On the left side, those are not like terms, so I can't do anything. On the right side, though, we know what 8 squared is. It's 64. Then our last step here, just get x by itself, subtract 4, and I get x equals 60.